Hello, today's lesson is going to be on absolute value inequalities. We recently covered equalities, so if you need to freshen up on that, go back, rewatch the video. I want you to think about inequalities like this. When we were dealing with absolute values, we said they were k units from a set point. Well, if this is our set point, this equation is saying the absolute value of x must be greater than k units away. Well, for instance, if that's k units and that's k units, the distance must be greater than k units. So it can be any point going that direction. But remember, we said it could go in a positive direction or a negative direction, so it could also be any distance this way. Since we have an absolute value that's greater than without the equal than bar, this k point is not included, and your graph would look something like that. These are the graphs that go outward. Sometimes we refer to these as OR graphs. The other type of inequality would be, excuse me, the absolute value of x is less than k. Same thing. On a number line, if this value is x, you are saying the distance is less than k units. Well, if this point is k and this point is negative k, the distance between x and k has to be less, so it can be these points. And again, it's less than, not less than or equal to, so it's an open circle. And if it can go in a negative direction, it can be between x and negative k. On these graphs, the points are between the two values of k. Sometimes you will hear these referred to as AND graphs. They make a sandwich in the middle. Now the trick is, how do you solve these? Going back to our first example, absolute value of x is greater than k. We saw on the number line that x would be right there. And if we have positive k and negative k, our answer sets will be going outward from each of the k values, the greater than values. To set this up algebraically, if you notice, our answers are outside of x. We did say these were sometimes referred to as OR statements because we use OR to express them. Again, we're going to use two statements to represent one absolute value. So x could be greater than k, and that takes care of this bit right here. Or x could be less than negative k, which means to solve a less than inequality on our number line, the distance between x and k needs to be less than k and less than negative k. So we have the points in between. To write that algebraically, it would look like this. Negative k is less than x is less than k. Or k, x is between the two k values. This chart might help you remember where to do what when solving these. So for a less than equation, remember these are sometimes referred to as AND equations. We want the value between the absolute value bars to be between the values or less than negative c and c. So if we have a value here and we have a value here, we want it to be between them. It makes that type of graph. If it is greater than, those are what is referred to as OR graphs. And those must be, the distance needs to be greater than c or less than negative c. So if this is your c, negative c, and here's your c, our graph will go out like this. Let's do some examples. That's the best way to learn it. So we have the absolute value of 4x plus 5 is greater than 13. Immediately we see that our sign is a greater than sign. So greater than means our distance has to be greater than 13, or less than negative 13. So it has to be more than 13 units away. This was what we called an OR graph, and we know on a number line it's going to go outwards. So that's our hint. So for our first case, we want to take 4x plus 5, and it needs to be less than negative 13, or our positive case, 4x plus 5 is greater than 13. Solve each of these equations. We're going to begin solving this one by undoing the positive 5 on both sides, and we get 4x is less than negative 18. Divide both sides by 4, and we get x is less than negative 18 over 4, which reduces to negative 9/2. In our second case, we want to undo the positive 5, which we're going to do by subtracting 5 from both sides, and we get 4x is greater than 8. Dividing both sides by 4, x is greater than 2. To graph this on a number line, it's going to look something like this. Here's 0. Negative 9/2 is approximately negative 4.5. So let's put that in. Extend our line a little bit. Let's put 2 right here. And this graph does not include 2, but it includes all values greater than 2. And it does not include 4.5, but it does include all values less than that. Let's move on to another example. In this example, the absolute value of 7 minus 2x is less than or equal to 19. Again, this is less than 19, so we want our distance to be less than 19 units in a positive and negative what direction. We can call these AND statements. And when they're graphed, the graph needs to be between those 2 points. So using that, let's set it up algebraically in our two cases. My answer is between these 2 points, so I need to set it up as negative 19 is less than or equal to 7 minus 2x is less than or equal to 19. This matches our rough sketch up there. So to solve this, instead of doing the same thing to the left and the right to maintain equality, we do it to all 3 parts. So I want to undo the positive 7 in the middle, so I need to do it to all 3 parts to maintain equality. This is negative 26 is less than or equal to negative 2x is less than or equal to 12. Now we need to divide by negative 2. Again, we want to do this to all 3 parts. Remember, when we divide by a negative, that right there is going to change things. We have to remember to flip the inequality sign. So that gives me 13 is greater than or equal to x is greater than or equal to negative 6. Now, if we wanted to sketch our answer on a number line, it says that x is between 13 and negative 6. If this is 0, if this is negative 6, and if this is 13, it does include these 2 values because it is greater than or equal to or less than or equal to, and it is all the values in between.